For our next example, the Federal Trade Commission, or FTC, monitors pricing accuracy to ensure that consumers are charged the correct price at the checkout. According to the FTC, 29% of stores that use checkout scanners do not accurately charge customers. So if you shop at 3 stores that use checkout scanners, what is the probability that you will be incorrectly charged at least one store? So this one is a little bit more difficult than the last one because of this word at least one. Okay, so we know that this is a binomial experiment because there's only 2 choices. We're repeating this experiment 3 times, and going to one store versus another store is pretty much independent of each other. So my n is going to be 3 because we're going to 3 different stores. The FTC says 29%, so that my probability is 0.29. And then my x, let's see, that's the interesting thing. I need to know the probability that we're going to be incorrectly charged in at least one. So at least one. So at least one could be either 1 or 2 or 3. This means this is going to be quite a lot of work. I'm going to have to find the probability of finding exactly 1 plus the probability of getting exactly 2 incorrect charges plus the probability of getting exactly 3 incorrect charges. Add those all up and then I'll get at least 1, because at least 1 is 1 or 2 or 3 all the way up to n. So this is a lot of work. But what I'm going to do is I'm going to do something a little bit tricky. Remember that the probability of the event happening at least once is equal to 1 minus the probability the event does not happen. So I'm going to change the problem. I'm going to try to find p of 0 incorrect charges, and I'm going to do that right down here below. So I'm going to use n equals 3 and p equals 0.29, and then I'm going to use x is equal to 0. If I can get the probability that we have 0 incorrect charges, then all I need to do is take 1 minus whatever that number is, and that's going to get me the probability of at least 1. Okay, so I'm going to kind of ignore this middle section, and I'll be right back to it in just a moment, and just really find the probability of 0. So the probability of 0 incorrect charges is going to be the combination of 3 choose 0 times 0.29 to the 0 times 1 minus 0.29 to the 3. So 1 minus 0.29 is going to be 0.71, which is to the 3 here. Okay, so now I'm going to get my calculator out. And I use 3 combination choose 0 times 0.29 to the 0, because 0 of them are going to have successes, and then times 0.71, so those are the failures, and that's going to be 3 times, because 3 failures with 0 successes. And this is going to get me the probability of having exactly 0 is 0.3579. We're going to round that up to, we'll just go to 794 places, that's fine. Okay, now that's not my answer. The question asked at least 1. So what I'm going to do is I'm going to come up here and I'm going to replace the probability of 0 incorrect choices with the probability I found, 0.3579. So the probability of at least 1 is equal to 1 minus 0.3579, which is going to be 0.6421. So that is the answer. I had to use it a little bit of creativity to find p of 0, and then 1 minus p of 0 to find at least 1. Let's do this again. Part B. If you shop at 3 different stores that use checkout scanners, what is the probability that you will be incorrectly charged in at least 2? Okay, so this is not quite the same as at least 1. So we have n is 3 again, my probability is 0.29 from the FTC's information. And then what is at least 2? Well, at least 2 means you can have 2 or you can have 3. So here I'm going to take the probability of exactly 2 plus the probability of exactly 3, and that's going to get me the probability of 2 or 3 charges. Now I could do the probability of 0 plus the probability of 1 and subtract it, but I feel like that's kind of about the same amount of work. Clearly on the one above, probability 1 plus probability 2 plus probability 3 is too much work here. Whereas 1 minus the probability of 0 was a whole lot less. On part B, well, it's about the same, right? Either add the probability of 2 or 3 together and get your answer, or add the probability of 1 and 0 and then subtract it from 1. That actually just seems like a little bit too much. So we're going to go ahead and work this out. The probability of exactly 2 incorrect charges is going to be the combination of 3 choose 2 times we have 2 successes, so that's 0.29 to the 2, times we subtracted 1 minus 29 from 0.29 before, and that got us 0.71, and that's going to have 1. Okay, the probability of 2 means 2 successes and 1 fail. So the probability of 3 means 3 successes and 0 fails. Okay, so that's the probability of just 2. So now I'm going to add that to the probability of exactly 3, which is the combination of 3 choose 3 times 0.029 to the 3 successes this time, times 0.71 to the 0, because we have 0 non-successes. So let's work this out. 3 combination choose 2 times 0.29 to the 2 times 0.71 to the 1, and that's going to be in the green 0.1791. And then I'm going to do the same thing for purple, but this time I'm doing 3 combination choose 3 times 0.29 to the third times 0.71 to the 0. And in purple, I'm getting 0.024, and the 8 makes that 3 go up to a 4. Then I can add these two together. To get the probability of at least 2 stores is going to be 0.2035. So whenever you're met with at least 2, you got to think about, what does that mean? Well, 2 or more. At most 1 would be 1 or less. So you really got to think about what at most or at least means, and then try to find your answer as simply as possible. And this concludes our lesson on binomial probability.